We're going to look at the Beers Law Lab, and in this lab we are going to be using our LabQuest, our SpectraViz spectrometer, a cuvette, which is just a plastic container that will hold our solutions, and the lab actually calls for us to use copper sulfate. And since I'm doing this from home, I've adjusted the lab and we'll be using nickel sulfate, but it's really not nickel sulfate. It's just a green food coloring in water to simulate the exact same thing that nickel sulfate would look like. So nickel sulfate is in this green color, as you can see in the bottles there. And I've already pre-mixed the solutions. They go from 0.4 molarity all the way down to 0.8 molarity. And I'm going to go through all of the steps that we would use to set up the lab. The first thing that we'll need to do is to calibrate our LabQuest and also to pick the light frequency that we need to look at. So what goes on here is we're looking at the color that is absorbed by the solution. So this green color that we see in these water bottles, that's the color that's transmitted. So on the opposite side of the color wheel is what we would be looking at as its absorbed color, which will be somewhere in the red range, but we'll look at that when we get it all set up. I've started the calibration process, and the first thing that has to happen is our colorimeter needs to warm up, and so it warms up for about a minute and a half, and that's the period that we're in right now. All right, we've gone through the warm-up period, and the next thing that we need to do is to finish the calibration by putting in a cuvette that has distilled water in it. And I just click on the finish calibration and let it finish doing its calibration. I've replaced the water that's in the cuvette with the 0.4 molar solution, and we're going to do a full spectrum analysis, and this will be how we are going to select where we want to set this up to absorb. I've zoomed in on the LabQuest, and we see a color spectrum there, and the line that is running through that is where the light is being absorbed at its highest at in each of those color bands. And so we're going to pick a spot somewhere, a point somewhere close to the top of the curve in the red area, and that'll be the wavelength that we're looking at as the wavelength that is absorbed most by this sample. Now I've stopped the data collection and I've moved the cursor. You can see where the lines kind of intersect there to the top of the peak, and down in the lower right hand corner it gives me a wavelength. And so we are going to be doing the rest of our analysis only at the 628.9 nanometer wavelength of light. That's all that we're going to look for when we do our data from here on out. Okay, so I've changed the mode to be events with entry, and I have selected my entry name to be concentration. The units are moles per liter. I've hit the play button. So from now on we'll hit the keep button, which if you go down to the bottom of the screen on the LabQuest is below the ABS, or right there beside where the red stop button is the keep, and you'll select that every time as you put in a new sample. And then what we'll do is we'll type in the correct concentration. So what I have in the cuvette is the 0.08 molar solution. The 0.08 has been replaced by the 0.16 solution, and this is our amount that we have. The 0.24 molar solution is now in. This is the 0.32 molar solution that we're looking at here. This is the 0.40 molar solution, and the last of these solutions that we are going to look at. Next, I'll show you the data table and the graph, and then we'll start manipulating the graph. This is the full data table of all of the data that we have collected in the lab. You can see what every value is, and also what the absorbance is in each case. This is the plot of the points on a graph. Now we're going to go to Analyze. So under the Analyze window, we'll look at Curve Fit, and then we'll move on from there. So I'm going to click on Curve Fit. This is the screen that we get with Curve Fit, and then under where it says Fit Equation, we need to choose an equation to fit that. Now this is a linear equation, so we'll just pick the straight line one when we look at the drop-down menu. So this is our drop-down menu, and it has all these different graphs that we can look at, and this just looks like a linear graph, so we'll choose that one. So our linear graph here, which gives us in normal slope-intercept form, y equals mx plus b. And our correlation is 0.99, that you would want to be close to 1. And the root mean square of the equation, you'd want that close to 0. Both of those values are pretty close. So the data lines up fairly well. Now the next part that we'll be looking at is we can also use our data that we have to figure out the concentration of an unknown solution. So we'll take a reading with an unknown and we'll just plot it on the graph. So wherever the absorbance shows up, you trace it out where it intersects your line, drop it down to the x-axis, and then that will tell you its concentration. I've replaced the cuvette with the unknown solution. Now the unknown solution I keep in this Mountain Dew bottle because the bottle's green, the solution color's green, and you can't really guess on what you would think that the solution is. But what this will allow you to do is if you take the value, the absorbance value, 0.74, it's bouncing around that last digit a little bit, but it looks like it's in the 745 range. So let's just call it 0.745 as our absorbance. Then if you put that on the y-axis, come across to where it intersects the line in the graph that we just did or that you're going to do on your own, and then drop it down to the x-axis, that'll tell you the absorbance. This is a Beer's Law lab. Beer's Law helps us to calculate concentration from absorbance or transmittance.